Okay, so this is section 4-2, standard form of a quadratic function. Our learning objective is to graph quadratic functions written in standard form. So just to remind you, the standard form of a quadratic is f of x equals ax plus bx plus c. It's what we do usually when we use a quadratic formula to find a zero. So that's our standard form. So we're going to take a look and find the vertex, axis of symmetry, maximum and minimum value, and the range of y equals negative 3x squared minus 4x plus 6. Okay, so for this first one, we're going to do it graphically. So we're going to use our graphing utility to find the vertex, axis of symmetry, max or min, and the range. All right, so we put our function y equals negative 3x squared minus 4x plus 6 in our graphing utility. Our vertex is up here. So it's at negative 0.667. That is a rounding to negative 1/3, comma 7.333, which is also rounded 7 1/3. So our vertex is at negative 1/3, comma 7 1/3. So when we right here we have our vertex, negative 1/3, comma 7 1/3. Our axis of symmetry is at x equals negative 1/3. Do we have a maximum or minimum? And in this case we have, since we are facing down, we have a maximum value at 7 1/3. So when you list your maximum value, that is the y coordinate of your vertex if you're facing down. And then we need to find the range. So the range of this function is all y values less than or equal to 7 1/3. And that's how you use your graphing utility to find the vertex, axis of symmetry, max or min, and the range. All right, so now we are going to do that same skill just using algebra instead of a graphing utility. So when we have a graph, the axis of symmetry, so make sure you highlight this real big. I know it's small here, but this is really big important. The axis of symmetry is negative b over 2a. So you have to identify a, b, and c so that you can find the axis of symmetry. The x coordinate of the vertex is x equals negative b over 2a. And the y coordinate of the vertex is whatever you get when you plug that x value into your function. The y-intercept is going to be at 0, comma c. Those are big time important pieces. So let me show you how to use those formulas to find the important pieces of a quadratic in standard form. So it says, what is the graph of y equals negative 2x squared plus 2x minus 5? The first thing we have to do is identify a, b, and c. So a is negative 2, he's in front of the x squared. B is equal to 2, he is in front of the x. And c is equal to negative 5, he's the only one hanging out on his own. The axis of symmetry is x equals negative b over 2a. So I'm just going to plug in negative b so b is 2, over 2 times a, which is negative 2. Then I'm going to simplify that down. That's a negative 2 over negative 4. Negative and negative is a positive. 2 over 4 is 1/2. So x equals positive 1/2 is our axis of symmetry. So I'm going to go put that on the graph. X equals positive 1/2. So that's a dashed line. That's our axis of symmetry. The x-coordinate of the vertex is also negative b over 2a, or in our case, 1/2. The y-coordinate is whatever our function is when we plug in the 1/2 into our function. So do the math with me. 1/2 squared is 1/4 times negative 2 is negative 1/2. Negative 1/2. 2 times the 1/2 is 1. And minus 5 is minus 5. Negative 1/2 plus 1 is 1/2. 1/2 minus 5 is 4.5. Negative. So our y-coordinate is negative 4.5. So we're going to plot our vertex, which is at 1/2, 4.5. So it is at 1/2, negative 4, and 1/2. I know we are facing down because I have a negative in front. All right, since c is equal to negative 5, the y-intercept is at 0, negative 5. Y-intercept 0, negative 5, which is right there. The reflection of 0, negative 5 across the x-axis is, across the x equals 1/2 axis of symmetry, is this point right here, which is, no, it's at 1. Right, sorry, my circles are not circling. So it is at 1, negative 5, just reflected. And we plotted both points. Check. Since a is less than 0, the graph opens down. Draw a smooth curve through these points. And then we're done. So the bridge problem, he's a Zhaozhou bridge in China. If you look, we have a nice little parabola going on right here. So we are going to represent this parabola using this function equation right here. We want to know how high is the arch above its support. So essentially we want to find the max. So on your paper, go ahead and write that function and then write find the max. So we're going to take our function, we're going to identify a, b, and c. C is an easy one, he's 0. A is the guy in front of the square. And b is the guy in front of the x. To find the maximum value, we're just going to plug in a and b into our negative b over 2a, and then we're going to plug that value into our function. So that's just a simple calculation. times negative 0.001075. Plug that in your calculator and you get, which is 61. So that's this distance here. So we're going to plug 61 into our function, this guy right here, to find what our maximum height is. So f of 61 equals negative 0.01075 times 61 squared plus 0.131148 times 61. And we plug that into our calculator, and our y value at 61 equals. Alright, so for the first one, when I put in 61, I got negative 4. And for this guy, when I put in 61, I got 8. Negative 4 plus 8 is 4. So my height at the highest arch is 4 feet. That's our max. And that's the end of the lesson today.